Now I want to actually go through a full hypothesis test with using critical values and critical regions. So using rejection regions for a z-test. So what you're going to end up doing at the end, how you decide if you reject the null or not reject the null, is using these two pieces here. So if your test statistic falls in the rejection region, then you reject the null. And if it's not in the rejection region, then you fail to reject the null hypothesis. And again, I didn't label it in this one, but your rejection regions are the shaded region. So here, this one and this one. Okay. Now, just a reminder that if you fail to reject the null, it doesn't mean that you accept it as 100% true. It simply means there's not enough evidence to reject it. So you're kind of saying, like, at this point in time, there doesn't seem to be anything wrong with the null, so we can't reject it. But again, we're never actually proving it 100%. So your steps, just to kind of review hypothesis testing, the first thing you need to make sure for this section is that you do know sigma, because we're using normal distributions, right? If you know sigma, you're using the normal curve. We need a random sample, and either the population is normal or your sample size is at least 30. You do want to state the claim, and you do want to identify the null and alternative hypotheses. You want to make sure you note your alpha or your level of significance. You do need to determine the critical values. You can use that with table 4, or you can use that doing inverse norm. Along with that, kind of the same idea as you're going to determine the rejection region. So kind of steps 3, 4, and 5 go together, where you're drawing that picture, you're shading, you're finding that critical value. Then you're actually going to go ahead and find the test statistic. Now, this is the same test statistic we use with the p-value method. So most of the process is exactly the same. It's just kind of the last piece, the last couple pieces where we make a difference here. But it's the same test statistic. And then you're going to make your decision. Do you reject or do you fail to reject the null? And then, of course, interpret that decision in words, like make sense of that decision in reference to the claim. So are you supporting the claim? Are you not supporting the claim, etc.? Too many chords. I'm trying to get some of them out of the way. All right, so let's look at example 3 here, and let's go through the hypothesis testing procedure. Now, this is one where, you may want to have the procedure with you as you go through until you get really comfortable with all the guidelines. So you may want to put that on a note card or just print out an extra copy, just something to have near you. So let me read it through first. It says, employees at a construction company and mining company claim the mean salary of the company's mechanical engineers is less than that of one of its competitors, which is $88,200. A random sample of 20 of the company's mechanical engineers has a mean salary of $85,900. Assume the population standard deviation is 9,500 and the population is normally distributed. At alpha equals 0.05, test the employee's claim. So the first thing I'm going to do, I'm going to run through these steps. I'm going to verify that sigma is known. It is. We're told that the population standard deviation is 9,500. So remember, sigma is the population standard deviation. Is the sample random? It is. We're told that it's a random sample, right here. So it is random. Now our n here is only 20, right? I have 20. So my sample size is quite small, but we are told the population is normal. So we are okay to proceed. So again, we're just kind of doing that requirement check. So I usually just call this the requirement check to proceed and make sure we have all those pieces in place. Now we're going to go ahead and state the claim, state the null, state the alternative hypothesis. So our claim here is that the mean salary of the company's engineers is less than one of its competitors, which is 88,200. So they're saying that the mean salary is less than the 88,200. That's what their claim is. Now, this is strictly a less than idea, right? So remember that your null hypothesis is the part that has the equal piece to it. So our claim is going in the alternative here. So our alternative hypothesis is that the mean is less than 88,200. The opposite of that idea is that it's greater than or equal to. So again, your null doesn't have to be straight equality, but it has to have an equal piece in there somewhere. So as a review, your null hypothesis either has equality, greater than or equal to, or less than or equal to. And your alternative hypothesis either has not equals, less than, or greater than. So that's how we're setting it up. And the claim should fall into one of those categories as well. The third thing we need to do is make sure we note the level of significance, and we're told here that alpha is 0.05. My fourth step is to find the critical values here. So along with the critical values, let's make a note here. You have to think about what kind of test is this? Is this left, right, or two-tailed test, right? So that's the other thing you have to consider here when finding your critical values is what kind of a testing region are you looking at? And that comes from your alternative hypothesis. So let's use a different color. Kind of another note here. If your alternative hypothesis has a less than, you're looking at a left-tailed test. If it has a greater than, you're looking at a right-tailed test. And if it has a not equal to, you're looking at a two-tailed test. And that's something that we talked about in previous videos. So just kind of a little review there on how do you figure out what kind of test you're looking at. Okay, so in this case, our claim has a less than, so we are doing a left-tailed test. So when I draw that picture, all my alpha then is going to be on the left. So I want to go ahead and find that value then that helps me find this rejection region, right? So I need that Z value. So I can either do second bars inverse norm. Now my area to the left is 0.05 and my mean is my mean is 0, my standard deviation is 1. So if I plug all that in, I have 0.05, comma 0, comma 1, and I get about negative 1.645 here. So that's one of those rare z-scores that we use 3 decimal places for. Remember, this is one of the main ones we've seen. If you are not using your calculator, then you're going to your table in the back of the book, and you're looking for that area of 0.05. So let's see. So 0.05 is right kind of in between here, right? There's 0.0495, 0.0505. So it's right smack in the middle. So that's why they use negative 1.6. And you can see it's 5 and 4. So they use 4, 5. So it's kind of right smack in the middle of those two values. So that's one that you do want to kind of keep in mind. That's a pretty popular one that we've seen a few times now. All right, so we kind of did steps 4 and 5 here, right? We determined our rejection region. We have our critical value there. And now we're ready to go ahead and find the test statistic. So step 6 is we're looking for the test statistic here. So I'm going to use this formula right here. So Z equals So let's see, in this case, my sample mean was 85,900. My population mean, this is from your hypothesis testing, is 88,200. My sigma is 9,500. And then my n is 20. So I'm looking at the square root of 20. Sorry, I'm just getting my notes because I already did the answer out. And so what you get when you use your calculator is about negative 1.08 for your test statistic. So now we're in part 7 and 8 here. And I'm going to redraw my picture only because my other picture is a little bit squished now, but you shouldn't have to redraw this. So here is my cutoff, negative 1.645, right? And here is my rejection region. And I want to know, where does this fall in the graph? So negative 1.08. So this right here is negative 1.645. So is it smaller? Does it go to the left? Or is it bigger? Does it go to the right? So in this case, our value falls more like right here, right? This is sort of like where z equals negative 1.08 would fall. It's not in the rejection region because it'd have to be smaller than negative 1.645. It's about negative 1, so it's closer to 0. So it's in between. So our z value of negative 1.08 does not fall in the rejection region. So we fail to reject the null hypothesis here. So if it's outside that shaded region, you are going to fail to reject the null hypothesis. And there's a little reminder about that right there. So now we just have to go back and make a statement, right, based on the claim. And sometimes this is the hardest part. So think about what's going on here. Let me get a new color. All right, so our original setup was right here, right? And this is our claim. Now, we are going to fail to reject the null hypothesis, meaning that we're not going to reject the null. We're going to keep the null. So this sort of means like keep the null hypothesis, right? You're not proving it, but we're going to keep it for now. So we're accepting this null hypothesis here. So if we're accepting the null, I shouldn't say the word accept because we're not proving it. But for now, we're not saying that there's anything wrong with it. So we have to keep it. So if we're keeping the null hypothesis for now, then basically I do not have evidence for the claim. So in this case, there is not enough evidence to support the claim. In this case, that the mean salary is less than $88,000. Okay, sorry, it's a little squished there, but we're not going to support the claim here. Again, the null seems to be fine, which means that I don't have support for the claim. So we cannot support the claim in this case. All right, let's do another example here. We'll do one more. So a researcher claims that the mean annual cost of raising a child age 2 and under by married couple families in the US is $14,050. In a random sample, so I should say of married couple families in the US, the mean annual cost of raising a child is $13,795. The sample consists of 500 children. Assume the population standard deviation is 2,875 and alpha is 0.10. Is there enough evidence to reject the claim? Okay. So in this case, we want to reject the claim. So let's start from the beginning first. So do I have sigma? I do, right? The population standard deviation is $2,875. I do have a random sample here, so a random sample. And my N is actually equal to 500. So we are definitely over the 30, so we're good. And we don't have to worry about if the population is normal or not. If it is, great. If it's not, it doesn't matter. Our sample size is plenty sufficient. So now we have to figure out, okay, what is the claim that we're talking about here? So a researcher claims that the mean annual cost of raising a child by married couple families is $14,050. So our claim here is that the mean is $14,050. Now, this claim has equality in it. So if it has equality, it must go to the null, because remember, the null has to have some sort of equal piece. So our claim actually goes to the null position here. And the opposite of equals is not equals. So we have our null and our alternative hypotheses here. Our critical value, or sorry, our confidence level or acceptance level here is alpha equals 0.10. And then for steps 4 to 5, we're going to really start thinking about that picture. Now, notice that my alternative hypothesis has a not equal sign. So if it's a not equal sign, we kind of went through the 3 processes up here. It's going to be a two-tailed test. So what's going to happen in my picture is that I need to have some of that alpha in both tails. So I'm going to have a little bit over here. I'm going to have a little bit on this side. And they should look equal. I know my graph isn't perfect, but you can kind of get the idea, right? Now, remember your alpha is 0.10. So I need to put half on each side. So you split that in half. So 0.10 divided by 2 is 0.05. So this side is going to have 0.05, and this side is going to have 0.05. Now, I do need to know what my critical values are. So I'm going to just continue my work up here. So I'm kind of continuing with step 4 and 5 here and finding those critical values. So you can do it with your calculator. You can do it with the table in the book. If we're using our calculator, again, remember you do area to the left. So for the first one, it's pretty simple. The area to the left is 0.05. Mean is 0, standard deviation is 1 when we have z-scores. In our second one, you just want to be careful because, again, you want the area to the left here. So for this one here, I want the area to the left. Well, I take 1 minus whatever is on the right. So that's 0.05. So my area to the left is actually 0.95 here. So I'm going to put 0.95 in my calculator. Now, again, you don't have to do both of them because it's going to be the same value, just different signs, but it does help if you are concerned that when you check them, something's going to be wrong here. Right, and then the other one. Again, this number here is one that we've seen, quite a few times. So hopefully it's starting to look familiar to you. So there are my 2 z values. And again, if you don't like doing it that way, then what you're going to do is you're going to go to your table here. And I'll just do the negative side. But again, you're looking for that area of 0.05 in the table. And you're just trying to find it the best you can. And what you're going to see is that it's right halfway between these 2 values. So that's where the negative 1.6 comes from, and then you're going halfway between the 4 and the 5. So again, hopefully this value is a familiar one at this point, and you can remember to use 3 decimal places instead of just the 2. So this z-value here is negative 1.645, and then this z-value is positive 1.645. My next step is I do have to do my test statistic. So I'm going to take that formula here. All right, now here, just be careful. This is our sample mean. So our sample mean is up here in the paragraph. It was 13,795. And the mean for the population is what you're testing. So that 14,050. My sigma was 2,875, and I have a very large sample here, which is nice. I have a sample of 500. So when you divide that all out, you are going to get about negative 1.98 for your value. So what you want to do is fit that 1.98 on your picture. There we go. Fit that negative 1.98 on your picture. Where does it go? So think about it, right? So it's definitely on this side. It's a negative. And negative 1.98 is almost negative 2, which is going to be somewhere down here. It's going to be past the negative 1.6, right? So maybe it's like right here. So that is definitely in the rejection region here. This one is too. So in this case, our test statistic falls in the rejection region. So we reject the null hypothesis. So looking back here now, let's kind of see what that means. So for me, I just kind of like to go back to my original statement for a second. I say, okay, I'm going to reject the null. So basically I'm saying, okay, I'm rejecting the null. Last time I was failing to reject it, so I was like keeping it, right? Here I'm rejecting it, I don't want it. So if I'm rejecting that, that means the alternative hypothesis makes more sense here. So it seems that the value is not 14,050. So is there enough evidence to reject the claim in this case? Well, the claim, right, our claim, use different color here. Right, our claim was an equality statement. So our claim was the null, and we rejected the null. So in this case, we are rejecting the claim. So there is enough evidence to reject the claim. Okay. So once you've determined if you're rejecting or failing to reject null hypothesis, you kind of need to go back and look at it and say, okay, what am I rejecting? For me, I like to cross it out maybe, or kind of circle what I'm keeping. That helps me process it a little bit better. But you need to think about what your claim was, because that's also important. Here, our claim happened to be in the null position. So when we rejected the null, we rejected the claim as well, right? Because the claim was the null. In this example here, this one was different. Our claim happened to be on the alternative position. In this problem, we ended up keeping the null. So if we kept the null, then the claim didn't make sense, right? Because it was in the alternative position. So you have to really think about, am I rejecting or not rejecting the null? And secondly, where is the claim? And that is really how you make that determination of how to answer that last piece. If you're still having trouble, a couple videos back, so I believe it was a 7.1 handout, we went through what to say. So how you could start your sentence there based on where your claim was and if you were rejecting the region or not. So you may want to go back to some earlier videos and earlier lecture notes if you need to, just to kind of learn how to write that part of it. Just flipping through real quick. Yeah, that was section 7.1. So if you need to have some guidelines there, there's a little table we talked about there and how you can get started with your wording for something like part 8.